Yes, it's work. Thank you.
You're welcome. No worries.
And I see, yes, we're ready to start. So everyone, every guys are here.
Understood. Okay, then let us start. So, welcome everyone to our first class. Today we will go to like really basics, the skill set that every data engineer need to be master of it, and that skill is SQL, as you will guess, which basically I assume that's been questioned during your interview processes with all of them. So let's do it bit interactive way. So let's understand where we are and what kind of knowledge we miss or we already know. Yeah. Is there a question, guys? Okay. Then if you have any question, feel free to ask. Let's start from a bit different thing. Do you know what kind of workload exists? If you know, you can kind of shake hand in Zoom. How many of you heard about things like OLTP or OLAP?
I know that it's about transactional and analytical, but I don't know exactly.
Okay, no worries. Then let's start from understanding of what kind of workloads we have, because it will help you also in the future. So as you mentioned already, we have basically two kind of workloads. Let me like do workloads. Most popular ones, of course, are OL. I don't know why I'm always writing T here, but it should be OLTP. LTP. Second one is OLAP, and there is a new one that collecting more popularity is ACP. So let's understand what it is and what each of them makes and why we need these differentiations. First one, OLTP, it's online transactional processing. So it's pretty describe itself. It is a lot of transactions going on. So we can divide these from two perspectives: the number of transactions, and let's say, and the volume of data for each transaction. Yes, data volume. Let's say it doesn't matter, is it read or is it write transaction, no matter how many transactions we are sending and how much data each transaction is using. Typical use case in OLTP is when you have a lot of transactions going on, like a number of them is really high, and each of them uses a small subset of data. So you will definitely see a lot of databases like this. Any kind of well-known SQL database like Postgres, MySQL, Postgres. A lot of NoSQL databases also fit in this area, like MongoDB. So what's the matter here? You are sending a lot of requests, but each of them scans only some small amount of data. Typically, for example, we are making some user request. Yes, you are liking something, for example, in Facebook. It is very small amount of data, but that kind of transactions happening in really a lot during a second, like 1,000 transactions within a second. Yes, so there is a lot of transactions and a few data scanned or modified during that transaction. This is typical use case for OLTP workload. When you see these kind of use cases that you need to send a lot of transactions with small amount of data, you should know that you need to investigate or start from OLTP database or the solution that handles OLTP workload. Okay. Second one is OLAP, online analytical processing. So from long times, it's been like clear that you can't run analytical workload on the OLTP databases because this is typically like operational sources and they are working in production, they are serving to customer or things like that. So you don't have enough room there to run queries against OLTP databases because it will harm database and it will make it slow down. Yes, it won't, in some cases it can also go down. So you can run this workload on OLTP databases. So what you do, and people a lot of think and they come across with solutions which called data warehouses, WH. And these guys are designed for, let's say, again, number of transactions, but this time there are really few transactions, like maybe couple during a minute or one or two during a second. But data volume here is much, much bigger. Again, doesn't matter. It is read query or it is write query. There are things like grouping all, let's say, user base by some status or things like that. They are analyzing vast amount of data. These kind of solutions are Redshift. Also, some other providers like Oracle have setup of data warehouse. So Oracle DVH. Okay, and you guessed that point. Yes, there is a lot of not a lot of transactions. They are going really few. Typically, they are running some business users or some machine learning developers or data scientists and reporting engineers, and they are scanning typically a big amount of data. And that data should be scanned on high velocity. And typically, you are running some analytical workload, which means we are running some group bys and summarizing function and things like that. That's why there is a huge difference between how we store data here and how we store data here. Here we are talking about row storage. Here we are talking column. Column. Do you know what is the difference, guys, between row storage and columnar storage?
As I remember, in a row storage, data is saved in rows, and in column storages, it's by column.
Exactly.
It's kind of there are some difference about speed and how you process this. For example, group by operations, I know they are better for column storage.
Exactly. That's the way it is working. Let's say you have a table which has 4 columns. Yes, it will be stored like each row together. That 4 columns will be here. Yes. And every time you request anything from this table, it doesn't matter how many columns you are taking and things like that. It's not matter. It is going and reading like whole row. There is no difference between select star and select, let's say, some columns. Yes, there's no difference. it is reading row. In this case, you have each column, let's say, divided by either blocks or something else. Of course, it is also handling the relation between these rows. Yes, something like this. There's some relations, but you don't see. And there is a huge difference when you select star and select some column. And there is huge difference between these two. They are not equal, like this. Why not equal? Because if you choose the one column, it is going to analyze only this one. So it is not going to read whole row. So this is very crucial difference to understand, because this is the way how columnar storages became efficient, and you need to understand this in order to create efficient queries on top of columnar storages. Yes, and this way of storage is taking much fewer space rather than the row storage. Row storage taking a lot of space, like 3-4 times more space. But you need to understand these basic differences between them. Okay, we have also the last few, I would say even less than a few years, things called online archive processing, what we refer under the archive processing. There's a cases when you need to analyze some data daily, weekly, quarterly, or even in yearly basis. So there's like really rarely accessed data. It's like this, yes, number of transactions. They are typically either monthly, either quarterly, these kind of queries. And in this case, you are analyzing a huge amount of data, like all historical data, everything you have. Why we are differentiating, making difference between these two? Because they are really similar to each other. You can run this workload on this guy, but typical difference is that we make, especially in AWS, it is pricing. As far as this kind of queries running on a huge volumes of data and they are running really rarely, you don't need always running clusters or things like that. So that's why we differentiating this kind of workload. And typical solutions to work these kind of things is Athena in AWS and Redshift Spectrum. Spectrum. So you will need to understand, and you will feel when you come across with these kind of things. In these kind of things, we are talking about like storage. It is typically S3. It is there should be object storage. In these kind of solutions, we always have division between compute resources and storage resources. Typically, they are working like some object storage, or it can be block storage like HDFS or things like that. But it is completely different from computation engine. It is the way how we can reach these kind of volumes to be analyzed. And also these things we are saving in some files, and the structure of that files also also the matter of discussion. But it is in these two cases we are not worrying about files. In a case of archive processing, you need to worry about files and how you are organizing your files. And that files are typically Apache Parquet. And again, Apache ORC. This is columnar storing files. They are specifically designed to be scaled and to be handled by online analytical processes. By the way, this is data lake, typically data lake that you heard a lot of time here. And this is data warehouse, and this is our operational databases. Okay. Do you guys have any questions regarding these? Do you get all the reasons why we are differentiating between these kind of workloads?
I have a question and not
Yeah,
really understand what is the price economy in using OLTP concerning to a lab.
Okay, it is bit AWS specific question, and this is really good that you give that AWS. These data warehouses, typically in all clouds, specifically in AWS, running in some clusters. For example, you are running Redshift cluster, it is giving you some machines running in the cloud, and it is charging you by hour. As long you run, as long you will be paid. Doesn't matter how many queries you will run and things like that. It's no matter. In case of data lake solutions like Athena, you are paying only for data being scanned. So you are paying.
Clear. It's clear. Thank you.
Yeah. So that is the reason why when you run frequently queried, that frequency you can divide something like this. If you run something daily, more than daily, yes, daily is the division. If you run daily, you will go to data warehouse because it is will be too frequent and the price of data lake will be more. If it is less than daily, it is something weekly, monthly, or quarterly, or bi-weekly, something like that, you can consider to use data lake. Okay.
Yeah, okay, thank you.
Any other questions?
I would have a question about how much is the difference between selecting something between data warehouse and data lake. How much time it takes for both?
Okay, there is no exact timing to say that this will be faster rather than other one, because it is depends on how you will organize your files, what kind of solution you are using. In most cases, data warehouse are faster than data lake. Yes, you can take that into account, that data warehouse will have faster access. Also, with data warehouse, you have ability to run a lot of update queries. It will handle them better, much better rather than data lake. So from speed perspective, there is no like exact speed that this is the speed of these readings and things like that, but generally data warehouse is faster than data lake.
Okay, I see.
I thought you asked before the difference of row and columnar. Correct?
No, I meant data lake and data warehouse, but
I see.
I guess the row one is faster in transactions and slower in analytics.
Yeah, exactly. When you need to, in this case, in row one, you have a lot of secondary data structures that can help you. In case of columnar storage, it's becoming a bit tough to implement that kind of that kind of secondary structure. We will see that in next part, but yeah, that's why you can use it row structure under the high transactional load.
Okay, thank you.
Any other question?
I have one.
Yeah, I have I've heard about something called lake houses. How does lake houses differentiate? I know that they have some features of data lakes and warehouses.
Yeah, exactly. It's a bit tricky to differentiate because I saw two cases or two interpretations of warehouses. One, when you're combining data warehouse with data lake, you can have that with Redshift and Redshift Spectrum. So you have Redshift running and it can run through Redshift Spectrum can read data lake. One implementation is that. In that case, what you do, you have both workloads. You have analytics and archive. You can utilize Redshift database here, yes, handle your workload. And when you need analytic processing, use the same database to read the files of data lake. It is pretty popular solution in AWS. Second way is when, if I'm not mistaken, Databricks using that. They have bit different understanding of lake house. So I can't exactly say what they are doing because I don't know enough regarding Databricks. But in scope of AWS ecosystem, you can achieve that with Redshift and Redshift Spectrum to have that mixed workload.
Yeah,
Especially
understand. Thank you.
when you need to join your data from here to data here. Yes, like say you have 7-year history data and you want to join it with your just half-year operational data to get some analysis. I don't know. You need to use this Redshift Spectrum Lakehouse thing to combine these two data sets together.
Yeah, I understand. It's good to have such, in between solution. But then, what is the point of using, for example, antenna if you can always, for example, use Redshift?
From Antenna, you can't actually query Redshift. This is not working. So in any case, you will need to combine data that you have in data warehouse and in data lake. You are going to use Redshift Spectrum. So there is no opposite direction. Yes, to use Athena to get data from there. And what other reason can be there? Yeah, basically that's it. I think that's the main reason that we have Spectrum. And also the Redshift gives you very popular JDBC connection, which can be useful. Which will be a bit tricky with Athena, because Athena do have some ODBC connection, but it is a little bit different. So you will have like easier setup with Redshift. If you have already set up Redshift, you will have easy integration of your data lake with your data warehouse rather than integrating your data warehouse to your data lake.
Okay, thanks.
Okay, any other question?
You said then in OLACP, we widely use the Parquet and ORC file formats. What are their major benefits compared to JSON and CSV, JSON lines, or something like this? Like, what are the main benefits?
I'm afraid that you will ask what is the difference between these two, because typically this is really tough question. If we say JSON between Parquet, at first you can't divide JSON. You can't divide JSON. It is flat file. Parquet, how is it structured? It is composed from small blocks. So data already partition it there, and you can read this data parallelly. In JSON, you can't do that, or in CSV. Also, you can't do that. You need to read this in a single thread. In Parquet, you can also, in Parquet and ORC, there is header files, which contain some brief information regarding all these blocks. So sometimes you don't need to scan all that block. You need only header file to be scanned, and you may get like structure, some understanding what these blocks contain and things like that. So if you need to get structure, you don't need to read at all this block. You can read only the header. So it is much faster. Also, Parquet saves you a lot of space. If we compare any flat file, even our raw, with Parquet have like 3-4 times compression. Like if it is 100 megabyte, let's say, here you will have something 30 or 25. It depends a little bit from your structure of your data, the cardinality and things like that. Typical compression is an uphill. So if you need to read Parquet data, you will need to transfer a lot less data into your processing part. So it is giving you speed as well. Do you get my point?
Okay, I understand. Yes, and you also said that JSON we like have to read all the file, but okay, what about, for example, JSON lines format, where we have each JSON in like not a really big JSON, not one big JSON, but for example, the file is divided into small JSONs on each line, so we can check only that JSON that we need.
Understood. So they are lines, yes? Can you read them parallelly? You need to read whole file and then divide it to lines, yes? You can directly read them. You can't read some portion of that. So in case of Parquet and ORC, you can. You don't need to read this and then divide it between two parallelize. Things like going to about how, that we will store in rows, yes, because CSV also row format. You can like read one line at a time, but you can't read it parallelly. In case of Apache Parquet, you can. You can also like imagine Parquet as archive, yes. For example, you can open archive and read just one file, yes, but you can't open file and just read some subset of that. Do you get that point?
Okay. I think yes.
Let me please add one more point here in favor of Parquet. Well, it is columnar format. That's the main benefit, I think, which allows all other benefits to happen. Because it is columnar, the data in each column is collocated. That means that data of similar nature is located close, and that allows also efficient compression, because that data are from the same set. The items are similar, and also this saves time, for example, seeking to certain places in file and reading portions. You can read entire blocks of the very thing you need, very specific column.
Yeah, that's exactly right. So you can think about like Parquet is the implementation of this kind of storage, like columnar storages. You have all that analytic power and things like that with Parquet. Also, there is a lot of community behind the Parquet, and there is solution things like Apache Arrow and stuff like that. I don't want to overwhelm with technologies, but that kind of technologies make Parquet to transit files a lot, in higher speed rather than you will transit JSON and things like that. And there is a lot of things under the hood that going. Things like how you store JSON in memory and how you store it in the file format, how you store Parquet, and how you analyze it in memory. This Parquet format is like general, like old convention, yes, to use that for analytic workload, and everyone like trying to optimize that for that workload. And there is a huge community behind that, and they are constantly adding features. Typically, if you come across with the problem of like someone complaining that data lake not working fast, you need two things to check. First, are they using Parquet or ORC? Second, how they are structuring their files, partitioning and things like that. But it is not, we are not going to dive in that part at this point. Our main goal now to understand what kind of workloads we have. Okay?
Yes, thanks.
No worries. Any other question? Okay. Then let's proceed. So today we will talk about exactly this guy here. We are going to talk about OLTP databases and all the things that we continue to discuss will be a matter of OLTP databases. Yes, we are also, though you can use the same SQL with the data warehouses and data lakes as well, but today what we will talk is belong to OLTP. Okay. So SQL, structured query language. At first, can someone ask this kind of question? Why we use tables? Do you know why the first databases are designed with tables and why we are continuing to use tables in any kind of analytical, especially analytical databases?
Tables allow us to stack data with similar structure.
That's close, but it is bit too technical. The real answer is not technical. The real answer is how people's brain works. Yes. If you look at the table, the structure of table is the way that you can digest the most information that you can. So if you looking at table from just one glance, you can understand a lot of information from that, because your brain, starting from your school and I don't know, childhood, from how they call diaries, or what the name that they feeling in the school, the subject. Yes, everything is tabular. Your schedule, your I don't know, calendar, everything is tabular. So from the beginning, natural way, people starting to train their brain in tabular way. That's why tabular format is very the most understandable for human. It is the way that you can capture the most information. In case of JSON, XML, XML and other things, it is like specifically for programmers, because we are developing our brain on that sphere as well. But still we are capturing the most information from tables. So that's why the most number of databases are oriented on tables. And the first of them that we have, like from 18th, I believe, they are also using this tabular format because it is the most easiest way to understand, the most fast way for human to get the information, to digest the information. So here we are going to talk about OLTP databases and structured query language in OLTP databases. Alexei mentioned couple things regarding SQL, like filtering, sorting, and the joins and things like that. But before all the stuff, we need to understand how SQL code gets compiled. Which steps are doing like first. What is, let's say we have this kind of queries: select star from table, join other table, ID, let's say, and stuff like that. And from there we have where, let's say this is T, this is O, T, let's say status, for example, status equal to A, and let's say o.date bigger than state. So we can say the sequence, which part of this code will be executed first?
Maybe join.
Okay, join. Another suggestions?
Maybe from the end, from the filtering.
You mean from here?
Yes, just from the filtering, we will select only that is which accepts the filter.
Okay, and you need to have a data to filter. Yes, first.
Yeah.
Oh, yeah.
So in order to have data, you should start from
Select.
From select.
I guess it will select all from both tables.
it's closer, but not exactly exact answer. You are starting from. You are not starting from select. Select coming at the very end. At first, you should start from. From which table you should get your initial data. You can't go forward. You can't validate these things because, for example, if I say column A and column A not exist in this table, it means that all these things will break. Yes, so you should first load this table to understand what kind of columns you have in order to specify that columns. So it will start from. So what will be our next step? Any ideas?
Join maybe.
Exactly, join. Of course, it should join another portion of data to like clearly collect all the data in a single place that you need. Next step, which will be?
Where?
Of course, where?
And the last one will be select,
Exactly.
as we are selecting rows and then filter what exactly columns do we need.
Yeah, exactly. This is the sequence that SQL uses, and this is very crucial to understand. So, because if I do something like this, left, what will change in this query if I add this left here?
Well, if there is no connection from the left from the table T, these values will still be present in the select and the values will be null.
That's the first answer that coming to mind, but exactly left here, we don't change anything. Because how we are doing? We are doing from, we are doing join, then we are doing where we're saying that date should be greater. If there is no date, we are anyway filtering them out. So this left here won't change anything at all. Do you get the point?
Yeah, the filter, there is no where.
Yeah. So in order to stay left, we need to move this part, which belongs to this table, into our own statement. So it will be join it on different condition, and after that we can filter. So in this case, this left will take effect. The because of this is the sequence that SQL formatter and engines using is from, join, where, then select. Okay. Then we have another guy here, group by, let's say 1. Then we have having greater than 1, let's say. Yes. And I think the sequence of these guys are pretty obvious. Yes. Now it is going group by and then having. Okay. You need to keep in mind this structure, because in my career, personally, me, especially when you're working with the data scientist or I don't know, data analyst who have really not deep understanding in SQL, they can write left join or something here and then implement this kind of thing exactly in this way, and they don't understand why their reports or some analysis are wrong, because they are basically taking wrong data. Also the same thing with group by and having and things like that. So from as the data engineer, you should clearly understand which will go. So you in your career, there will be a lot of cases that someone will refer you and say, hey, I'm running queries. It is not delivering the right results, maybe something wrong in database, and you need to not only check your database side, but also check their query, because sometimes they can just write the wrong query. They didn't understand that. Here also another thing that we putting in select, it is window functions, which are coming again during select, and then order the by something is coming also after select, and then limit, which is coming after the very end. Limit, offset, and things like that. Everybody knows, yes, what is limit, what is offset.
I don't know about offset.
Offset is like you have like 10 rows, yes. If you set offset 10, let's say you have 100 rows. If you set offset 10, it will start to read from 10th of them. And if you say limit 10, it will be like from 10th to 10 rows. Like it is skipping, yes, offset skipping, starting from the first.
Yeah, I see. Thanks.
Okay, this is the thing. We get the meaning of the, we get the sequence of execution. So it is should be like very in our like very in our mind always. So every time we are going to have any joins, you are going to have the problem of these guys here. Sequence you need to keep in mind. And for as the best practice that I can suggest you to like naturally avoid from the these kind of things, always write the where clauses, let's say, yes, some filtering options next to your join table. So that way you will always know that you joining right proportion of your table. Unless you need this guy exactly here, but it is pretty unusual that you have left join and something here. Yes, if you need something here, you will need to also do some and now or now close to fix that point. Okay. So any questions regarding the sequence, how SQL query getting executed? Okay, let's move forward. So now let's investigate some joins. What kind of joins we have? Who can say?
Left join, right join, cross join, full join.
Left, right, cross, full. Any others?
Is cross join the same as the inner join?
Which join?
Inner join. I'm familiar with inner join, but not familiar with cross. Maybe they're the same.
Inner join, okay. Inner join, any other things? Do you heard about, let me remember how it's called, Cartesian join, Cartesian, I don't even remember how it is writing. Okay, so left join, right join, full join, cross join, inner join. Basically, these are two. When you have no condition, it is on 1 equal to 1. And this is kind of called the Cartan multiply of two sets. Let's say you have one data set with 10 rows, another one with 2 rows or 20 rows, let's say. If you do cross join, you will get 200 rows, like all permutations of these two. And now they are rarely used. Indeed, you will always need to, practically, you will always need to avoid these kind of situations when you are doing cross join or when you're doing like Cartesian join. That maybe, I don't know, in some solutions or in some technologies, yeah, that you will need to think about that, but basically avoiding from that because they are just showing you permutations. Okay. So left join, I think this is the most popular way to explain how left join works. Yes, it is taking all the part from the left. Yes, so if you have table 1, table 2, it will take all the rows that have some connection, all the rows from table 1 and those ones that have connection with table 2. So let's say you can have something like this: select from table 1, left join table 2 on table 2 dot id, for example, equals to table 1 dot table 2 underscore id. This is the popular way, like table name underscore id to enforce references. Yes. So what will this deliver? This will deliver everything from table 1 and the rows that matching from table 2. We have another guy here, right join. Let's do the second way of right join. Right join, it is basically the opposite of the left join. It will deliver you this part. So vice versa. Typically, in practice, I use left join like 99% because it is easier to understand. You just putting if something match with the table, your original table. Yes. Right join is typically left join is more frequently used rather than right join. It is easier to understand. I don't know. It depends, but basically in the same scenario with right join, you will get everything from table 2 and only matching rows from table 1. And if there is no matching rows for that table 2 row, you will get all that null and things like that. So in your interviews, maybe there will be some question how to filter or how to get all the, if I'm not mistaken, we had customers and orders. Yes, guys, in our interview questions. And orders. So and we are asking to get like all the customers that don't have any old order. So if you need that, you just need to add here like t2.id is now taking into account that your sequence from joined and where. So after this line, your data set will be combined together. So if you know that this is left join, so if there is no order, your customer line will be with null fields. You are putting some null and you up and running, you are getting all the customers that don't have any orders, for example. Yes, this is the our question from our interviews. Do you get this point? This left and right part?
Yes.
This is fairly easy part. Full join basically taking everything, like combination of left and right join. If you do left join and then right join and union them, you will get the full join. And inner join taking only the one that is matching. So this is the small thing here. Okay. Inner join also very like popular, but be attentive with that, because in some cases the thing that I practically come across with that, if you have some data issues, not always you can use this file guy here, because it needs to be referential in order to get that data. You may have missing data. If you have in your query some missing data that should be there, but it is not there, and some differentiation, some difference in result and things like that, first check in case of join, is it matching completely? Is there some rows that should be connected, but there is wrong ID or something like that? You can use this kind of clause with where clause to understand, is there something that you need to add? Maybe there is no matching row or something wrong there, and you will need to come across with the solution. Okay. For data engineer, there is another very important topic regarding joins to optimize them. Yes, you need to understand. I don't know, is it too, Alex, what do you think? Is it overwhelming to talk about algorithm of joins, like how they are getting executed?
Alexey Digorev, yes.
Probably yes.
Okay, then we will skip that part, but we will talk about that parts in maybe other day, because it is very important for you to understand the algorithm of joins and how can be two data sets be combined together in order to be able to optimize some queries, do query optimizations and performance, and be able to read the execution plans and things like that. Okay. Next part that we going to do is the grouping. Yes. So what we are using for grouping in SQL? Is there any idea? But keyword
Group by keywords.
Yes, exactly. So what we have in group by, we have a lot of functions for grouping. Group by, basically most well-known of them is sum, max, basically any kind of average, AVG. We have even mode in some cases, which is the most popular row, let's say most popular value. So as you can see, it is coming at the very end of group by, at the very end of the select statement. So here, group by, sometimes depending on SQL database that we are going to use, it can be before select or it can be after select. If it is after select, you can use this guy, like here. You can see that just said group by first column. But if it is before select, you can't use this. You need to specify the like all things like, I don't know, column name and things like that. Okay. In Redshift, you can specify this guy. In Postgres, you can. In MySQL and Oracle, I don't remember how they implement that part. And we have having also to filter by grouped results. So if you have something like it is typical case. So when you need to check is something unique or not, yeah, what you are doing select by some, let's say it is ID or whatever from some table, grouping by ID and having greater than 1. So if this query delivers some result, it means your ID field or I don't know, email field is not unique. So, or some other field, I don't know, for case of name field, of course, it will deliver some result. So this is the way to use group by having to, for example, check uniqueness for your data set within your data set for some field. Okay. Do you have any questions so far, guys? Regarding
No questions.
No questions. Okay, nice. Then let's go for aggregation functions. First, when we using that, it is really some specific case, but they are really handy to use. When we need some aggregated data, like not from the one row, how, for example, let's say in select, if we don't have group by, we need to use some simple single row function, yes, like I don't know, plus, minus, or I don't know, apes and things like that. But what if, for example, we need some data in this row which coming from aggregation of results? Yes, let's say query like something like this. We have customers and orders, yes, here. And we want for each order to, no, for each customer to get, a moment, let me understand what kind of window aggregation use case we can have for these two tables. Let's say for each customer, the first order date, but it is not. Let's say we want to see orders, and for each orders customer, this to see the maximum order that customer places, something like order 1, yes, its order price, for example, is $1, but this customer here have another purchases as well, and we want to see maximum purchase that this customer did, which is maybe $10, yes. So maximum purchase for this customer is not in a group by, not in a single row. You can find it from a single row. You need to scan all data set. Yes, you need to scan all purchases for this specific customer. Yeah. So what you will do, you will go to your, let me remove this. You will go to your orders table. You will join it with your customers table on something. And here is where the magic goes. Of course, you will get the order ID easily. Let's say it is OID or that, let's say price or whatever. And here when things going challenging, yes, you need to get maximum, let's say, order from this specific customer in this row. How you can do that? You can do that through aggregations function. How it is going to be, let's come across with the syntax. It is going to like max, let's say, or or dot price. Here is the thing, over is the over partition by part E on by customer ID, set dot ID, for example, yeah. Okay, this is enough. And here, this way you will get max order. How it will, what it will do? It will take from your data sets. So it is executing after this join, obviously. It is taking all data set, partitioning it by your customer ID, like creating buckets for your each customer, yes, and combining all rows of your customers in that buckets, and calculating this function for that part. So it is taking maximum from this one, maximum from this one, maximum from this one, and putting it here. It is the way like do multi-row function in single row query. Do you get the point, guys?
Yes.
Yeah.
Beside this order by, we have here also case. Let's say we don't want the maximum price. We want like first time purchase. Yes, when this customer did the first purchase. So instead of doing this, we can do first underscore val. Let's say purchase date, order or order date. Here, let me clean this up. We will do another things, order by, let's say, order that date. And this will give us first value, and it will be the same, of course, the mean or max date, but I will explain difference why I'm checking these guys, why I'm doing exactly the order. But it will do, it will again divide into buckets. It is the partitioning basically by customer ID, and each of these buckets will sort by date, and will take first value from that. Okay. Moreover, so you even can do something like this. You can have rows between unbounding proceeding, unbounding proceeding, and unbounding following. This is really long to write. Let's concentrate. What is this rows? This rows clause, basically what it is doing, it is controlling your window. So you, with partition clause, divide your data set into buckets. With order clause, we are sort them. And with row clause, you can change the size of your window. So you are not taking everything in the bucket and taking only just subset of things. Like when you have some question like what is the first order date between these months, you will need to implement that part here to even more reduce your window in order to get some subset within the partition. Okay. From my side, I would suggest do not try to remember all this syntax, because even when I am writing some SQL query for window function, I am going and checking some documentation to recall some points here and how it is writing, because it is really long to write, especially when you need to define all these subsets and some window stuff here. Okay. Is there, guys, any question regarding these parts? Do you have any question regarding all the, I don't know, rows and something connected with SQL? I don't know.
I have one a question regarding joins. I've heard about, I've seen actually an outer join. Is this the same as full join?
No, outer is the keyword. Like the novel way to write left join is like write left outer join.
Ah, so it's left outer or right outer, yes?
Right outer, or yeah. This outer now is really obsolete, and it is a really like old-fashioned way to do that. No one now writing like outer. Everybody writing like left join, right join. We are not writing even inner now, yes, because join by default is the inner join. So we have left, right, full. Sometimes can be like full join on some on two clause and get the or permutation with Cartesian Descartesian multiply. So this outer is just the old way to writing, but it doesn't change anything. It is the same left join.
I see. Thank you.
Okay. Any other questions?
Yeah, I'd like to point something out. When you talk about getting the maximum value when you are grouping by some criterion, as I remember in SQL, when you write select max of some column and then add grouping by, then by default it returns really max values in each group, not in all the data set.
When you have group by clause, yes. But when you don't have group by clause, and you do need to see all of them. For example, if you write something select max, let's say date from table, it will give you only one date, yes, the maximum one from data. True. Yeah, but when you need some other columns and you need each row, but some multi-row result from that, you need to use window function.
Yeah, window function much more powerful, I see.
Yeah, you can basically figure out and do it in not in window function and some with clause. Let me touch also with clause. What are you familiar with clause?
No.
With clause.
Oh yeah. You can kind of you can with using this you can get some table, and using this table you can you know, build up some additional queries.
Exactly, it is creating like it is novel name in with is common CTE. I don't remember how they common table expression, something like that. We are defining like virtual column, yes, S, and giving some name. Let's say my table. We are putting some SQL here.
You know, it's like a mechanism of subqueries, looks like.
I would say yes, but the reason of with clause it is to give bit more clearance in your code. Yes, to your code to be more clear, more understandable, and things like that. And here I can select start from my table. So what you can do to substitute sometimes window functions, you can have with close, some analytical functions here, and then join this data to the original table. And you will have some impression of the window function. And in some cases, there can be performance differences between these two ways. It is a little bit tricky to understand which way will be, and indeed you need to just write them and understand which one will be more performant and which one will deliver results faster, I don't know, easier and things like that. But yeah, in some cases you can use with close, define some analytical question here, and then join it with raw data and have the same same functionality as we have with our window functions.
If I'm not mistaken, this Windows functions work faster than usually because it's kind of analytical function. And
it depends. It depends actually, because window functions for optimizer, there is a module in every database which is called optimizer, which is creating the plan how this query should be executed. And for optimizer, it is easier to understand window functions rather than these weird and complicated things. But sometimes that cases especially can be with the distributed systems, because in distributed systems it is easier to optimizer understand with close sometimes, not always, and create some subtasks rather than use window function. But anyway, you need to be try and understand which one is faster. It is not not always clear, and there is no clear guidance that in this case this one will be fine faster. No, you need to try and understand.
Okay. Will we discuss some, advanced stuff about performance? How it works in general?
Not at this session, but I believe at some point we need to have that kind of session, or we will just share with you some materials regarding that, some information regarding that, and you will investigate, and we will have some QA session or something like that.
Yeah, that's cool. Thanks.
So what else we have regarding SQL? Numeric foreign key indices, subqueries. Okay, so as we mentioned, there is also subqueries, so you can write subquery in, let me show you. You can write basically in any place. You can, instead of writing here table, you can write some subquery and use the result from that subquery to join. You can write subquery in from clause. You can write even in where clause, but that subquery should return only one row in one column. You can write it in select clause again, but that subquery should return one row or one column only. And also, there is things called lateral, where you can combine some data with lateral clause, and there should be subquery if I'm not mistaken. But this subquery can refer to some column on this table. Understood? In join also you can put some column from here to here. So you can have something like this: select star from table 1, join, and here you can write some subquery like select star from table 2, where table2.id equals to, let's say, table1 table2.id here on 1 equal to 1. What it will do, it is going to every time for each row here. This is a really bad way to write join actually, but it is possible to do something like this. It is going to, for each row, do some sub-select into database and get one row joined into this database. So as you can see, we are referring within your sub-select the table of 1. But of course, this is not always good idea. It is definitely bad idea to do something like this, but you have that functionality as well. And you can, in from clause, you can use lateral command. Not all databases asking you to use lateral. Sometimes you can just add subquery here, but in mostly it is asking some lateral here, and you are referring to your data, or in joint clause you are referring to your data. Also, another use case of using subquery, which is pretty popular and can be used only in OLTP databases. Remember that we are talking about OLTP. Do you remember the question regarding our customers and orders? Yes, where we should have the all the customers that don't have any orders. Yeah, here that we specify with join, where, and some null function. We can write the same thing without any join, and here in a where put not exists or exists and subquery here. If this subquery returns some result, this row will be shown. If this is not returning anything, it is not shown. And something like our subquery that we just wrote with reference to our table. We can write here, and it will deliver the same result in OLTP, and basically it will be same from performance standpoint as well. No much difference if you are using some indices and things like that, but they still can be difference. There will be a lot of difference in case of not OLTP databases, and if in case when you are not using indices during your filterings. So this is also a way to figure out with the really small amount of data, and this is the way to do the same thing with bigger chunk of data. So if, let's say, you want to check for just one customer, yes, do they have order or not? Yeah, exist is more is better way to do that. If you want to take all customers, it is better to use left join, because left join have a lot of algorithms under the hood that making it much faster from filtering perspective rather than just ordinary where filtering. Yes. Do you get this point of exist and exist clause and the subqueries?
Yes.
Yeah.
That's nice. I think that's basically everything from SQL querying that we need to know. Do guys, I missed some point, Alexei or Rustam? What do you think? Or Rustam is not here.
Very interesting presentation. I think I learned few things from here.
Oh, thank you. Your words like very warm from me, Alexei, as far as you learned from me. You being the mentor of program learned from it. It's really nice to hear that.
Yeah, thank you, Haik.
Yeah. Any other questions, guys, from our interns? Generally about all this stuff that we scratched here.
Yeah, no, it looks mostly understandable, and I think in practice there will be maybe some more questions.
Mm-hmm. Yeah, no
I say
more.
that yeah, in practice there will be maybe questions, but for now there is no.
Oh, maybe I have a question actually.
Mm-hmm.
I didn't quite catch the difference between partition by and group by having.
Okay. So group by having, group by what it is doing, it is actually how to say it. In case of group by, you are like creating in buckets, yes, your data. You are dividing in buckets, yes, based on some, I don't know, name, surname, whatever. And you are getting only these buckets. You are not getting data within them. Like you have, if you have like two hikes there, yes, you will get only one. Yes, in case of group by.
Yes.
In case of partitioning and in case of using window function, you will get again two hikes and the same data there. It won't be like compressed, you know. So if you have some data set like hike, like Haracha and Haracha. Yes, when you group by this, and I don't know, let's say you have also other columns and you calculating some analytics. When you group by these by name, you will get only hike and Haracha, 2 rows. In case of using partition by, you will get all these data sets and some analytic result here. Analytic result for these two will be the same, but you won't be reduce the number of rows. You know, sometimes window functions can be combined also with aggregation with group by. In some cases, it is possible. In some solutions, they are giving some errors. And sometimes you will need to use some distinct if you want to exclude all the repeating ones and stay only with the distinct data. But main difference is think that this guy will save all your rows and group by will reduce the number of rows and you will return only these buckets, not the all data. In case of partition, you have all data plus data from buckets that you get from this partition and all the things. In case of group by, you have only buckets data.
Okay, I see. Thank you.
Yeah, it is kind of combination of raw data and summary. You know, with group by, with window functions, we are calculating some summary. In case of using window function, you have raw data and you have summary. In case of using group by, you have only summary. Okay?
Okay, yeah. I think I understand. Thank you.
You're welcome. Any other questions? Okay, if we don't have questions, we can basically finish our SQL querying session. I would say we will definitely have another sessions to deeper dive in data modeling and how we are like creating databases and things like that, and more the database design part. And I think we will discuss and schedule some time for that as well.
Yes, thank you, Haik. Could you please stop our record? And guys, I will share also with you some organizational issues. Okay.